I forgot to turn the lights off on Monday, so that one was hard to read when I went to save it. So, the next things on your pie chart talks about identifying numbers as integers or non-integers. Integer, by the way, these are in this little big packet that you've got here. And we did this Monday, so those two today. So, if you're in class, you'll have your homework all filled in. So, an integer is just a fancy math name for a signed whole number. So, -3 is an integer. 5.2 is not an integer because it has the 0.2 on the end. We're doing intermediate algebra? Yeah. Just getting here? Alrighty. Go ahead and grab those things off the side of the counter there. Right here. Sign in there, and this starts on homework day 2 in that packet there. So, we are classifying these as integers or not. -71.49 is not an integer because it has that extra 0.49 on the end. 13/3, again, is not going to be an integer because 3 divides into 13 4 times, but I got 1 left over, so I'd have 4 1/3, not an integer. 15/3, however, is going to be an integer. 15 is divisible by 3 5 whole times. 5 is a nice whole number, so 15/3 is an integer. And the bottom two, -99 and 30, are both integers. They're nice whole numbers, obviously. Hopefully you knew that. So, number 2 then. 28/7, is that an integer? Yes, that's equal to 4. 45/9, is that an integer? Yes, 9 goes into 45 5 whole times. 19/7.
No.
Nope, 7 doesn't divide into 19 evenly. -25.98.
No.
Nope, has that extra 0.98. And then 77. Yes. And one more for good measure. I'm going to let you do that one quick. Make sure she finds where we're at. All right, so homework day 2. So integers are just whole numbers. So that one's not going to be an integer because it has the 0.7. That one's not an integer because you can't reduce that. This is an integer. It's a nice whole number. This is an integer. And this also will be an integer because 7 divides into 28 4 times, so it'll be equal to negative. So, number 3. -6.7.
No.
Nope. 11/9.
No.
Nope. 25.
Yep.
Yes.
Yes.
-43. Yes. -27/8. Yes, you guys are just quick. The next one's there. You are classifying numbers as rational or irrational. Rational numbers technically are anything that you can write in the form of a fraction. But rational numbers can include a whole lot of things. Rational numbers, besides being fractions, could be whole numbers. If I have a whole number, I can put it over 1 and make it into a fraction, right? 5/1 is a whole number. I can also have terminating decimals. Terminating decimals like 5.2 is 5 2/10. So I can write 5 2/10 as a mixed number or a fraction. Also repeating decimals like 1/3. 1/3 can be changed to a fraction, or 1/3, it is a fraction. Repeating decimals, 0.333333 is the fraction 1/3. So when you're looking at rational numbers, technically they're fractions, but they include whole numbers, terminating decimals, and repeating decimals, as well as all your fractions. Irrational numbers. Irrational numbers are technically non-terminating, non-repeating decimals. What I mean by that is if you would grab your calculator and put in the square root of 7 and hit equals. You take your calculator and put in the square root of 7. What shows up on your calculator screen? 2.64 dot 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 keeps going and going and going. It never ends and it never repeats. So when you're going to get an irrational number, it's going to be something that you have a square root or some other radical, but they're just going to do square roots of something that doesn't come out to be a nice whole number, or it's going to be something with pi. What's pi besides something you eat? It's 3.14159 dot 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 dot, and keeps going and going and going forever. Usually we round it off to 3.14, but it really keeps going on and on and on and on forever. So when you're looking at your list, you're going to have two ways that you have irrational numbers. A square root that is not a perfect square is going to be irrational, and anything with pi is going to be irrational. All of the rest should be in that big long list we have of rational numbers. Terminating decimals, which is the top one, or repeating decimals, which is the top one because it has that bar there. Here, although we have a square root, it is a perfect square. If you do the square root of 49, you get 7, which is a nice whole number, which is rational. And then, of course, the bottom one is a fraction, which is what a rational number really is by definition. So when I'm doing these ones, what I do is I look for the irrational ones, because you have a whole lot less choices of irrational numbers. Pick those ones out first. The rest should all go in your rational column. So if I look at number 5, which two values on that list are going to be your irrational values? 19 pi and square root of 3. So we said the ones with pi and the square roots that are not perfect squares are irrational. The rest should be in your rational column. 5/10 is a fraction, which is what a rational number is. Then we have 6.82 with the bar, it's a repeating decimal. And then we have negative square root of 16, and 16 is a perfect square. So if we had to write it as a fraction, we could. So on number 6 there, which two of those are going to be your irrational values?
Negative 3 square root of 2.
Negative 3 square root of 2.
And pi.
And the bottom one, which is just pi. And so the negative 20, or the 24.89, negative 3.6, and negative square root of 4 are all going to be rational. All right, sign, fraction, addition, or subtraction, basic. On here, normally the negative in front of our fraction is applied to the numerator instead of to the denominator. And so if I have something like negative 5/6, they're going to rewrite it as negative 5 over 6 plus 3/5. I'm then going to find my common denominator so that I can create my equivalent fractions. So here, 6 times 5 is going to give me 30. 30 is going to be my common denominator. Instead of writing two separate fractions, I just usually write one big fraction and then do my numerators. 6 goes into 30, 5 times. Negative 5 times 5 would be negative 25. Then I have my plus. 5 goes into 30, 6 times. 3 times 6 is going to give me 18. Now I'm just going to do my subtraction. Negative 25 plus 18 would give me negative 7, so my answer is going to be negative 730. On the Alex program, on your final answer, they do like the negative out in front of your fraction. If you put it on top, they'll say it's correct. However, the negative really should go in front. So number 8, this one we're doing a subtraction Again, we're just going to start and go ahead and find our common denominator since we don't have any negatives in the bottom. Our common denominator here is going to be 15. 5 goes into 15 3 times. 3 times 3 is 9. I have a subtraction sign. 3 goes into 15 5 times. 2 times 5 is 10. And so 9 minus 10 would give me negative 1/15. Number 9, we're adding. Again, they have that negative in front of this one, so they're going to put the negative up with the 2. Negative 2 over 3 plus 2/5. My common denominator here again, since I have a 5 and a 3, is 15. And so 3 goes into 15 5 times. 5 times negative 2 would be negative 10. 5 goes into 15 3 times. 2 times 3 is 6, so plus 6. And then adding negative 10 plus 6, we get negative 4/15. So the next ones, they call these ones advanced. Technically in math, you're not supposed to leave the negative or put the negative on the bottom of your fraction. If you happen to have a Texas Instrument calculator and you try to put the negative in the bottom, it gives you a math error. So what they're going to tell you is if there's a negative on the bottom of the fraction, we're just going to put it up in the numerator instead of having it in the denominator. So this problem here, they're going to rewrite as negative 8 over 3 plus 9/4, and then basically do it the same way we did the previous problem. So my common denominator would be 12. 3 goes into 12 4 times. 4 times 8 would be negative 32. 4 goes into 12 3 times. 3 times 9, positive 27. And then we're going to do our math up there in the numerator. So if I have negative 32 plus 27, I get negative 5, so negative 5 twice. So on number 11, you'll notice they have a whole lot of negative signs and subtraction signs in there. I'm going to rewrite that as negative 4/5. I'm subtracting a negative 7/6. And when we subtract a negative, what do we do with that? We change it to addition. So we're really going to take negative 4/5 and add 7/6. Go ahead, find your common denominator and add those. And you ended up with an answer of 11/30. Holler at me if you have a question or you're not getting that same answer. I'm hoping you knew these ones. So number 12, go ahead, do that one on your paper. What you come up with on that one? Everybody else get that? I I just heard Amy. She's the only one who told me she got negative 97 over 45. Sign fraction multiplication. If you look at the LH program, they're going to leave all those negative signs in there. I think all the negative signs get confusing. So as a general rule, when you're multiplying, if you have an even number of negative signs, your answer is going to end up being positive because a negative times a negative is a positive. If you have an odd number of negative signs, your answer is going to stay negative. And so if I look at this one, it's got 1, 2, 3 negative signs in there. I know it's going to end up being negative. So what I'm going to do is I'm just going to put the negative sign out in front. Then I'm going to rewrite it without the negative signs. 9/4 times, I have a whole number, so I want to put that over 1, 2 over 1, times 5 over 9. Then I don't have to worry about all the negatives when I'm doing my math. I already know my answer is going to be negative. Since I'm multiplying fractions, I can do some canceling. 9 goes into here once and into here once. 2 goes into 2 once and into 4 2 times. I'm then going to multiply across the numerator and across the denominator. And so I'm going to end up with a negative. 1 times 1 times 5 is 5. 2 times 1 times 1 is 2. So negative 5/2. Normally in algebra, you're just going to leave the improper fraction. You're not going to use mixed number answers unless it specifically says write it as a mixed number, which hardly ever happens. So if you look at number 14, should my answer end up being positive or negative? A little louder so I can hear you.
Negative.
Negative, thank you. There's an odd number of negative signs, so it's going to end up being negative. So I'm then going to take 2/9 times 3/5 times 4 over 1. Can I do any reducing? The 3 with the 9. 3 goes into here once and into here 3 times. So if I multiply that, then I'm going to end up with negative 8/15. Go ahead and do the bottom one, number 15. And what do you get for your answer? 72 over 7. That's what I get too. And we know it's going to be positive because we had an even number of negative signs. (16), (17), and 18 have to do with those absolute values. Talked about absolute values on Monday being the distance of the number from 0 on the number line, which just basically makes your number positive. But before you can apply the absolute value, you have to do the math inside the absolute value symbols. So if I'm going to evaluate this first expression, I'm going to do the 10 minus 9 first. 10 minus 9 is 1. Once I just have one number inside my absolute value, I can then apply the absolute value. Absolute value of 15 is 15. The absolute value of 1 is 1. There's a subtraction between those two expressions. So my problem just says do 15 minus 1, which is 14. So if I'm going to do number 17, again, I want to start and simplify inside the absolute values. 6 minus 8 would be negative 2. I'm then going to do my absolute values. The absolute value of negative 2 is 2. The absolute value of 14 is still 14. There's a subtraction between them, so my problem's 2 minus 14, which is, whoops, negative 12. Now the third one, notice, has that extra set of absolute values. So you do the inside just like we did the previous two, and then apply the absolute value to your answer. Go ahead and try that one on your paper. And you ended up with an answer of 7. Good, that's what I got. All right. The next ones there have to do with evaluating exponents. If I have the parentheses around my values, I'm just basically going to take the base, which is the bigger number down here, to that number, the exponent, 2 times. So if I have negative 9 squared, means I'm taking negative 9 times negative 9. Negative 9 times negative 9 would give me positive 81, right? Now be careful on your calculator. If you're using your calculator and you don't put the parentheses around that negative 9, what happens? If you just put in negative 9 squared and you don't use the parentheses, what is your calculator going to give you? Anybody has a calculator with them? Gives you negative 81, right? This we'll get to in a minute, but if I follow my order of operations, means I have to square just the 9, not the negative. And so the negative stays on it. So be careful if you are grabbing your calculator and using it, that you use the parentheses if they're there. Negative 4 to the 3rd power technically means negative 4 times negative 4 times negative 4. If you do negative 4 to the 3rd power, you end up with, no? Negative 64. Now some of these common ones, squares, cubes, whatever, you might want to get to the point where you know them fairly readily if you don't already, because once we get into simplifying radicals, if you don't know what 4 to the 3rd is, and then they tell you to do the cubed root of 64, it makes that a lot harder. If you know these pretty quickly, then it makes these easier. If I have negative 5 to the 3rd power, what would be negative 5 to the 3rd power? Negative 125. 5 times 5 times 5 is 125. A negative 8 squared?
64.
Positive 64. Negative 2 to the 4th. I heard somebody whisper it. 16. And negative 3 to the 3rd? Negative 27. So the first ones there have the parentheses around them, and then they start throwing in the ones without the parentheses. Technically, if there's not the parentheses, that negative sign means it's a negative 1 times your value. So this means negative 1 times 9 squared. Following our order of operations, we have to do exponents before we do multiplying, like we talked about before. 9 squared is 81. 81 times negative 1 means that stays negative. As a general rule, if you're thinking about the odd and even signs being, if I have an even number of negative signs, it stays positive, and if there's an odd number, if it's in the parentheses, you count the negative the same number of times as the exponents. If it's not in the parentheses, you count the negative as just one negative sign. So in this case, there's going to be 3 negatives for the negative 2 cubed, 1 negative for the one on the outside. 4 negative signs means my answer is going to end up being a positive number. Technically, if I wrote this out the long way, this would be negative 1 times negative 2 times negative 2 times negative 2, which gives me positive 8. But if I'm trying to figure out is it going to be positive or negative, check how many negative signs you'd end up with. Here, I'm going to have 2 negatives because that's in the parentheses. There's also 1 on the outside, so 3 negatives altogether means that's going to stay negative. So if I have minus a negative 9 squared, my answer is going to be negative 81, right? Here, this negative only counts once because there's no parentheses. So if I have negative 4 to the third power, I end up with
64.
what's my sign? It's going to be negative, right? That negative only counts once. It means negative 1 times 4 to the third. So it's going to stay negative on that one. So negative 64. 24, if you look at that one, is my answer going to be positive or negative? It's going to be positive, right? The negative on the inside counts 3 times. You also have 1 on the outside, so there's 4 negatives. So I'm going to end up with a positive, and 3 cubed is 27, right? And on the bottom one, is that one going to be a positive or a negative? Negative, because there's just that 1 negative on the outside. So negative 64, 8 squared is 64. Again, as I said yesterday, the calculator's not going to be active. I suggest do them on your paper or in your head. If you need to check them with your calculator, check them with your calculator. But try to do them without your calculator. Now they're going to have you evaluate ones with fractions. Same rules kind of apply with your negative signs. In this case, the negative's on the inside of the parentheses. It's going to count twice, so my answer is going to be positive. And then I'm going to square this. So basically, I'm just squaring the 3 and squaring the 2. 3 squared is 9. 2 squared is 4. Or if you took 3 halves times 3 halves, you get 9 fourths. This one, notice the cubing is only next to the 4. So the numerator 5 is going to stay the same. And I'm just going to cube the 4. And so I end up with 5 over 64. So the first one on number 26, if you evaluate that, you would get
Negative 25 over 3.
negative 25 over 3. Now if you put the answer in as 25 over negative 3 on the Alice program, it's going to say it's correct, but it's going to say it's correct. However, as she pointed out, the negative really should go on the outside. The whole fraction's negative, not just the bottom number. This one here, we have the negative on the outside, so the negative sign is not squared. My answer is going to stay negative, right? So then I'm going to square that. I'm going to have negative 3 squared is 9. 5 squared is 25. So on number 27, if I take negative 2/3 and I cube it, it's going to be positive or negative? It's going to be negative, right? Because I'm cubing it, I'm going to have an odd number of negative signs. 2 cubed is 8. 2 times 2 times 2 is 8. And 3 cubed?
27.
27. Probably should have put my negative more in front, but oh well, we get the point. Negative 8 27ths. Now, this one here, you maybe can figure out if it's going to end up being positive or negative without going through all the work. Let's see what you think. On that one there, am I going to end up with a positive or a negative? Positive. We're going to end up with a positive. Why are we going to end up with a positive? This negative sign counts once. This one is going to count 3 times. So I'm going to end up with 4 negatives, which means it's going to end up being positive. If I simplify them each separately, I'm going to have a negative 5 over, and negative 4 cubed is negative 64. A negative divided by a negative ends up being positive. I find that most commonly mistakes are made with your signs. So you always want to go back and double check and say, okay, what should my sign be? Do I have the right sign on here? So number 15 wants us to follow the order of operations with integers, which means we just have signed whole numbers. Here, the only operations we're going to worry about are the multiplying and dividing is done before you do the adding and subtracting. We'll get to the longer ones yet. But when you simplify, if something isn't inside parentheses as an operation, you always do multiplying and dividing before you do addition and subtraction. So on this first one, we're going to do this division right here first. Negative 18 divided by 6 is negative 3. So we have negative 12, we're subtracting, and they put parentheses around it just to separate the subtracting from the negative sign. Then we follow our rule for subtracting. If I'm subtracting a negative, I end up adding. So I get negative 12 plus 3, and a negative 12 plus 3 gives me an answer of negative 9. So on number 29, what's the first thing I should do there?
Multiply.
The multiplying. Negative 15 times negative 2 is 30. 30 plus 5, you know. On number 30, what's the first thing you should do there?
Divide.
The dividing. 10 divided by negative 2. Negative 5. If I take negative 5 and subtract a negative 5,
Add it.
I end up adding and I get an answer of
0.
0. Negative 5 plus 5 is nothing. The next ones, probably out of all that stuff we just went over, are the only ones that maybe give you a whole lot of trouble. The other ones might give you a little trouble, but sometimes these ones get a bit tricky. Following my order of operations. My order of operations, parentheses. That means do inside the parentheses till you just have one number there, or you can't simplify any farther. Exponents. Multiplying and dividing go together from left to right, adding and subtracting from left to right. So way back when I was in school, we said, please excuse my dear Aunt Sally. Now my kids are coming home and I say, what do you do in math? And they say PEMDAS. It took me a long time to figure out what PEMDAS was, but that's what they were doing, was the order of operations. So if I'm going to follow my order of operations, I'm going to simplify inside the parentheses. In this case, this is the only part I have to simplify because this one only has one number in it. So I'm going to do 2 minus 3. 2 minus 3 would give me negative 1. So now I have minus negative 1 squared minus negative 1 squared times 3. I then do anything with an exponent. So I have to square that negative 1 on both cases here. When I square my negative 1, it becomes positive 1. But then I have that minus sign that I have to bring down and put in front. Same thing on the next one. I'm going to square my negative 1. It becomes positive 1, but I have a negative sign that I got to bring down and put in front. Times 3. I then do any multiplying or dividing from left to right. I do have multiplying, so I'm going to multiply here. And so I'm going to have negative 1 minus 1 times 3 is 3. Then I do my adding and subtracting. Negative 1 minus 3, negative 4. Now these ones, check with your calculator. Punch it in just like it looks with the parentheses. If you punch it in correctly, you should get the right answers, and that way you can check and make sure you do them correctly. If I look at number 32, first thing I'm going to do on that one is what?
Add what's in the parentheses.
Do what's in the parentheses. Negative 2 plus 4 is 2, right? Next thing I'm going to do,
Your exponents.
my exponents. So on the top I have 2 cubed. 2 cubed is 8. So I'm going to have 8 minus 1 on the top of that fraction. On the bottom I have this negative 2 cubed. Negative 2 cubed is
Negative 8.
negative 8. So I'm going to have negative 1 minus my answer, which was negative 8, And again, since I'm subtracting a negative, they'll put the parentheses just so it doesn't look so messy. So now I'm going to simplify. On the top, 8 minus 1 would give me 7. On the bottom, I have 1 minus a negative 8. 1 minus a negative 8 gives me 7, because I have to change it to negative 1 plus 8, right? And so now I have 7 over 7, which I can simplify. 1 is going to be my answer. Now, if you are going to use your calculator to check this one, you have to do the top separately from the bottom, or you end up doing a million parentheses. So you would just type in the top expression, see if you get 7, type in the bottom expression, you should also get 7, and then you can simplify your fraction from there. Go ahead and evaluate the next one on your paper there. Get an answer? I got negative 5. You guys get negative 5? So, first thing I did was simplify inside my parentheses. 4 over 2 was 2. I then did my exponents. 2 cubed is 8. 4 squared is 16. And then I had 8 plus 3 minus 16. And got negative 5. So we are going to go ahead and work on our pie chart. Some of you have to get started on your pie chart. But again, what you want to do for those of you who have gotten through your pre-test is look at those 11 topics. See if you have any of those 11 topics. Do those ones first. You might have to do some from the top if you went here and didn't get the top ones done yet. But do those ones first. We're going to work for about a half hour, so until about 10:15. And then we're going to do the next homework page. And then I can get these guys started. All right. Control Alt Delete here to log on. Click other user. Student ID number. You have your pink copy of your registration right there. And then SWCC should be the default. It should ask us to change it. Yep. What's the there we go. Okay. Go ahead and hit OK there. And then you're going to use a new password. Now this password will be the same for the network and your email. Every 6 weeks or so it's going to prompt you to change this password. So I gave you a piece, or maybe you picked up a piece of paper. The counter here. No, maybe you go over that pile of stuff. There it is. If you want to keep track of all your passwords, you can do that. This one's just going to be your student ID number and so forth. And then you're going to click OK. So you two can just go ahead and do your pre-test, and then once you finish your pre-test, I'll kind of show you how things work on here and what I'm talking about when I say look at your pie chart and see if you have any of these things to do. Maybe you'll get them right on your pre-test now and you won't have to do them. You should work now. Probably will make you do an assessment. I can't remember if you took the pre-test last fall. May or may not make you do this, that's good.
I need to.
You did it, okay. For sure. Most likely you did that.
What were we on with?
Who knows? They just said, you gotta reset now, and I said, okay, good. Don't know why it didn't wanna work, but they fixed it. Now you should get to the end of May. Alright, go ahead and go to Google Chrome. That seems to work a little better than Internet Explorer for whatever reason. The college's homepage is www.swc.tc. Most of the stuff you're going to use as a student is under the Life at SWC. There's a link to Alex, there's a link to e-learning, there's also a link to your email. We're going to go to e-learning first. And this again is going to be your student ID number, default password, SWCC again, and then we're going to change the password on that. You can use the same password. The network password will change, but your e-learning password will not change through the semester. So that's SWCC, and then whatever you want to use for your password on here. Let's turn off the camera. Still recording.